Hi, and welcome to Working with Big Data with ArcGIS API for Python. I'm Sarah Ambrose on the GeoAnalytics team, and I'm with Priyanka Tuteja, who works on the ArcGIS API for Python team. We are presenting this at Dev Summit 2021 virtually. Let's get started. So before we go into everything and show you a bunch of demos with sample notebooks, we want to make sure you know what ArcGIS GeoAnalytics Server is, as well as a very, very brief intro to the ArcGIS API for Python. If you're watching this online and you know what that is, just skip ahead a few slides and you don't need to listen. So what is ArcGIS GeoAnalytics Server? It's a toolbox that parallelizes computation to quickly analyze large amounts of vector, so point line polygon, and tabular data. It's just a collection of tools, and it's exposed through a server that has Spark to identify patterns, relationships, anomalies, and incidents in large amounts of data across space and time. So space, because this is ArcGIS, and we know that spatial data really matters, but time is also really important when you're accumulating a lot of data. Often it's time-stamped data. So that's why all of these tools, or many of these tools, incorporate time in addition to space. So how is it actually faster? I mentioned it earlier by accident, but it's because it uses Spark. So all of these tools that we expose, we have gone and we have written Spark code to create GIS tools that parallelize across your cores and your machines, and we've wrapped that up in a toolbox that you're able to easily use. So some examples of analysis that you can run. So the first one is which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours, and where are their hotspots of anomalous events? The second one, where have my delivery trucks traveled, and where is the highest density of unique delivery truck paths? And where do delivery trucks travel the slowest? And lastly, where and when are events happening close together in space and time? These are just a few examples. Priyanka is going to give you a demo and it's going to show a very different example. There are many applications that GeoAnalytics Server can be applied to. So I've talked a bit about GeoAnalytics Server. It's a toolbox. It's exposing these tools. You can run it in Server, but what if you want to automate it and run it through Python? So my very brief intro to ArcGIS API for Python, and this definition does not cover it. I really pulled out the things that are pertinent to this discussion. It's a Python library for spatial analysis, mapping, and GIS, and it's powered by WebGIS. So you're using Python and you're running things in ArcGIS Online as well as Enterprise, and then you can also do a few things locally. For GeoAnalytics Server, it's currently only available with ArcGIS Enterprise. So when we're talking about WebGIS here, we're talking about your base deployment with a GeoAnalytics Server. If you want to learn more about GeoAnalytics Server without talking about Python or how to access it through the ArcGIS API for Python, we do have a GeoAnalytics Server talk that I give with Noah Slocum, and that's available on demand at Dev Summit. You can also look at previous year's videos available on YouTube. So for the ArcGIS API for Python, what really stood out here for me is it's made for automation and data science. So automation, like you want to run your tools multiple times or you want to update your data, that's the type of automation we're talking about. And then data science, we know, is a very fancy way to say analysis. So if you've been doing GIS analysis forever, this is the data science that you're interested in. You're interested in aggregating points. You're interested in doing generalized linear regression. You're interested in doing everything available in PySpark, for example. All of that is data science, and that's what you can do through this GeoAnalytics Server. So how do they come together? We have ArcGIS API for Python, and then we have GeoAnalytics Server. What does it actually look like? So in the ArcGIS API for Python, we have the ArcGIS GeoAnalytics module. So this is how you access the GeoAnalytics Server tools as well as some of the data store functionality. So what do you actually get? Of course, I ruined it in the previous slide, as I always do. I get ahead of myself, but there's data connections. So how do you connect to your data? And then really, that's how you can connect to like Hive, HDFS, cloud stores, and I'll give you a few more details in the next slides. And we'll be hitting a demo very soon as well. And then there's tools. So the tools are broken up into a few different submodules, and within those submodules, there's tools for the submodules. Those submodules are just logical groupings to help you understand what those tools actually do. So in Analyze Patterns, for example, you might be looking for patterns in your data, some statistical analysis, whereas Manage Data, it's probably more management related, like calculating a field or just clipping your data to a boundary. In addition, and it's going to be shown in this presentation, is there's one very special tool that allows you to run custom analysis. So you can write your own analysis that's distributed across your GeoAnalytics server. So as for what we actually get in the modules, so in our GeoAnalytics module, we have 3 functions. We have get data stores, define output data stores, and is supported. And Priyanka will demo a few of those. And then we have a few submodules, which are how the tools are broken down. I just want to give you a quick overview before we jump into the notebook. I know that I can be suddenly like, what are we doing? So I like to see the words before on a slide and then do the demos. The Get Data Stores is one that we're going to demo first, and it creates a data store manager object. So that's in the GIS module. And then from that, you could do things like add your big data, add a cloud store, regenerate your manifest. And Priyanka has a great demo that kind of goes through all of these steps. So now that I've shown you how to access these data stores through Python, I want to actually tell you what they are. So with GeoAnalytics, we have a special data store called a big data file share. So these are very powerful for accessing data and writing data results back for GeoAnalytics Server. So with these big data file shares, you can read data directly from data in Hive, HDFS, shared folders, and cloud stores. And then it also supports a whole bunch of different types. So if you've been accumulating data in a type like delimited files, so like CSV, TSV, any delimiter really, shapefiles, Parquet, or ORC, you can use those in GeoAnalytics. I have an image on the right. So the image furthest back says Demo BDC. So this is a folder I have registered as a big data file share, and within it there are folders. So you can see I have AIS ship locations, bus locations, all the way down to Lightning, and then Uber trips. So each of those folders represents a single data set. So within that folder, there can be a bunch of different structure. It could be anything, it could be one file, it could be 5 files, it could have a bunch of folders. If you look on the image on the right, it says Lightning, that's a folder that we have, and then there are 12 shapefiles within it. All 12 of those shapefiles will be used as a single data set when I run this analysis. And that's the power and beauty of a big data file share. You could go add more shapefiles in there, and then the next time you run analysis, it would grab all of them. Priyanka will mention this a bit more and show a little diagram to explain it when she does her demo, which is right now. So Priyanka will do her demo now. Thank you.
Hi everyone, let me show you how you can make your data accessible to ArcGIS GeoAnalytics Server using ArcGIS API for Python. The GeoAnalytics Server allows you to register datasets in a format called Big Data File Shares. To use your datasets as inputs in a Big Data File Share, you need to make sure that your data is correctly formatted. You have to format your datasets as subfolders under a single parent folder that will be registered. In the parent folder that you register, the names of the subfolders represent the dataset names. If your subfolders contain multiple folders or files, all of the contents of the top level subfolders are read as a single dataset and must share the same schema. For example, here we have a file share folder. It contains 2 datasets, an earthquake dataset and a hurricanes dataset. When we register this parent folder, the 2 subdirectories, that is the earthquakes and the hurricanes, will be registered with the GeoAnalytics server. Now that your data is correctly formatted, you can connect to your ArcGIS Enterprise, which has GeoAnalytics supported. To verify that your GIS supports GeoAnalytics, you could run arcgis.geoanalytics.is supported. After that, you could create a big data store manager object using the get data store function. The data store manager object has a add big data method. This big data method helps to register your data by passing the data path of the dataset. In case your data exists on a cloud store, you can first register the cloud store as a data store and then can call add big data method to register the datasets present over the cloud store. Once the data is successfully registered, you can use the search method on the data store manager object to search for the data stores. Now you can see here that the data that we registered is visible here as registered as a file share in the portal. Here we get the fourth item of the data store object and create a big data file share object. Now, using the datasets property over this file share object, we can see how many datasets are available in a specific file share. Now, we can also use fileshare.dataPath to get the path of the big data file share item. If you have a multi-machine setup to perform distributed computation, you might also need to check if your dataset is accessible to all the GeoAnalytics servers. To do that, you can run the validate method and see if it returns true. If it returns true, you're all set to run the tools available in ArcGIS GeoAnalytics module. But if not, you might face some errors while running the tool. Big data file shares also have a manifest property that returns the schema of the datasets in your big data file share. And we can even edit these manifests of the big data file shares. For example, here we are changing the schema containing the spatial reference of 4326 to some other reference where this data belongs to. Now finally, we are all set to run the tools. Now we can search for the big data file share items using the type as big data file share, and that will result into the item list, and we can choose one of the items that we want to work upon and apply the tools.
Thank you, Priyanka. That was a great demo to show how we can quickly register a big data file share, check out the manifest, and then start to use it for analysis. The next thing I want to talk about is what analysis tools are available. So we've divided them into submodules, as I mentioned earlier. The first one is the summarized data module. I'm not going to go through all of the tools. There's a lot. Every release, we're adding more as well. So the summarized data module has tools that help you summarize and kind of synthesize your data into something more manageable. The use proximity tools are like create buffers and this new tool called trace proximity events, which looks for features or people or things coming in contact with each other for a certain amount of time and distance. The find locations toolset or submodule finds tools based on their finds features based on their location. So it's looking for incidents, it's geocoding, it's finding things that are similar or if they're dwelling in one location. So, a moving vehicle that stopped at an intersection for a long time. Manage data has a lot of tools. These are mostly for appending and kind of modifying your data in small ways. So that might be spatial, so dissolving the boundaries, or it might be combining one or more data sets together. One tool here, the very bottom one, is kind of secretly in there, and it's the very powerful one, which is run Python script, which allows you to run custom analysis on your GeoAnalytics server. And we will talk about that one more. And then there's analyze patterns, which lets you do statistical analysis as well as things that are like GLR or geographically weighted regression. There's some aggregation involved a lot of the time, but it's looking to actually analyze patterns in your data. And then data enrichment. So enriching your data. So maybe you have a bunch of points, but you don't have much information on them. These are two tools that allow you to enrich it. So you can enrich from a grid, which is a multivariable grid, which was available in the summarized dataset tool or module. And then there's the calculate motion statistics tool, which allows you to calculate statistics on tracks such as duration and distance. So the one tool I really want to call out here is our run Python script tool, because this allows you to write and run custom analysis on your GeoAnalytics server. So you can use other Python functionality and distribute that analysis across your site. So if you have a GeoAnalytics server site set up and it has 3 machines, this analysis will then distribute across your server. You don't need to go figure it out, set up Spark yourself, set up a whole bunch of machines and manage that cluster yourself. You can also create an analysis pipeline to chain tools together. So if you create a chain of 5 tools, you're going to skip that intermediate data output between them, and it's going to be a lot more efficient to run, both because it's going to save time not having to write the intermediate results, but also you're going to be saving space because you don't need to write those results. And then if you're familiar with PySpark, That's what's really powerful here is you get to use PySpark, which includes the machine learning libraries, their SQL libraries, and data frames to write your own analysis and really customize what you want to do on your GeoAnalytics server. So now Priyanka is going to show us a demo of using Run Python script for custom analysis.
While the ArcGIS GeoAnalytics module offers powerful spatial analysis tools, the PySpark package includes dozens of non-spatial distributed tools for classification, prediction, clustering, and more. So, can you get the best of both worlds? Yes, of course you can. You could now create powerful custom analysis by integrating PySpark and GeoAnalytics. We provide Run Python script tool that executes a Python script on ArcGIS GeoAnalytics server side and exposes Spark via a PySpark package. Layers from ArcGIS Enterprise can easily be used with both Spark and GeoAnalytics as Spark data frames. So, let's see how we can use Run Python script tool to change GeoAnalytics with PySpark, manage data with PySpark SQL package, and even perform analysis with PySpark ML. Well, why do we need to chain these together? Big data consumes huge disk space, and by chaining these analysis workflows together, we can avoid creating unnecessary intermediate layers and only save the final output to the data store. So in this notebook, you will see how we have performed multivariate time series analysis using Facebook profit model to forecast hourly value of PM 2.5 given the historic time series data for more than one time dependent variables. For example, relative humidity, wind speed, wind direction, etc. All by using Spark powered GeoAnalytics server. As a sample use case, I've used hourly data for year 2017 and 18 to train my model and predicted on 2019 month of January. So with the data available as a big data file share item, I have used describe dataset tool that gives an overview of your big data. If you provide sample underscore size parameter in the describe dataset tool, it will return a table layer containing the subset of your big data records, and it will also return a dictionary as an output outlining the geometry and the time settings for input layer. Now, because it's a time series analysis, we are also interested to do some temporal analysis and uncover patterns to understand our data better. So let's see how we could use Run Python script tool to find the most common instruments used for measuring parameters like PM 2.5, ozone, temperature, and so. So for that, Run Python script takes two parameters. It takes a code parameter and a layers parameter. In the code parameter, we pass a script in the form of a Python function. And in the layers parameter, we can pass a list of input layers that will be used to run our script. This Python function reads the first input layer as a Spark data frame and uses the group by operation that is provided in the Spark to group the data frame by a parameter name field and finally writes the output to the data store. Using the query method, we can view the output data frame and you can here see the different kind of instruments used to measure a particular kind of air quality parameter. Now similarly, we have got average PM 2.5 value for each county. And what's unique here in this script is that we have chained together Spark's filter operation and join features GeoAnalytic tool. So now we have a better understanding of our data. Let's convert our data into a time series dataset format. And for those who haven't done time series analysis before, let me tell you that a time series data frame with single variate generally contains a date field with another field containing a value corresponding to the row in the date time field. And because we have a multivariate time series analysis, we have multiple fields that are time dependent. Okay, let's go back and see how we created this time series dataset. So we got the necessary imports in the Python function. Because the script gets executed at the server side, we need to even import the libraries that we want to execute there. And then we have got the columns that we want to use. And finally, with some operations, we have applied a pivot operation and got one station time series data for 2017, 18, and 19. Finally comes the Facebook profit model implementation. The profit package provides intuitive parameters which are easy to tune, unlike classical time series models like ARIMA, LSTM. So even for someone who lacks expertise in forecasting models can use something like this to make a meaningful prediction over a variety of problems in business scenarios. All I have done here is I have used Spark's Pandas UDF group map function, which gives us the flexibility to use Python in order to forecast several time series at a time in a distributed manner. So now, this script here, we have selected the columns that we need to use for prediction. And after selecting those columns, I'm also providing the schema here. This is the resulting data frame schema that we need to provide for using Pandas UDF function. And then the rest of the code after we call Pandas UDF group map function goes in the Python language, and this is the vanilla Python code. And here what we are trying to do is we are trying to get rid of the nulls and the nans in the data frame, and even handling the negative values, because air quality parameters cannot have negative values, and if it's there it could be because of the instrumental errors. And then we have splitted the training and the test data frame. And now we are set to train the model. We're calling the Facebook profit model here and passing the daily seasonality and weekly seasonality to true. We're passing our time dependent variables into the add regressor method and then calling fit method. And that will train the model. Once the model is trained, you could call predict method over the test data frame and get the forecasted results. You could even plot the forecasted results, and that will create a graph to create, and this is the code I have provided to save those graphs locally onto your disk. And then we have saved the results in a WebGIS format, and the results will be available in the portal for ArcGIS contents. And once they are available, now finally comes the visualization of the predicted results. So to automate our workflows end to end, we also have dashboard sub module recently released. It can help you create dashboards programmatically, and we can easily see and compare how the model has performed in forecasting PM 2.5. The red you see the actual values, and the blue shows the values predicted by our trained model. And I think you can see yourself that model has done an excellent job in predicting and forecasting the PM 2.5 value. And I hope you enjoyed watching this cool demo, and now I would like Sarah to take over. Thank you.
Thank you, Priyanka. Now I want to show you some tips and tricks on how you can use GeoAnalytics and the Python API together. So the very first thing is to know that there's 3 different ways to read the documentation, or 3 different examples of documentation. There's the guide, sample notebooks, and the API reference. I personally prefer the sample notebooks because I like to learn by example, but I work with other people that prefer the guide because it gives a conceptual overview. And then some people love the API reference because it gives you the details of what you're actually calling and the parameters. If one isn't that helpful for you, I would definitely recommend trying out another one. And then as you become more familiar, you'll probably start to use all 3 together. But that's definitely the first thing when someone is running into issues. I ask which documentation they're using, and it doesn't really match with how they actually like to read documentation. So I suggest another one. Continuing on the trend of documentation, something that's really important to know is that these functions are built on the REST API endpoints. So we have ArcGIS Enterprise, and the way that most things access ArcGIS Enterprise are actually REST calls through the REST API. The Python API is built on top of the REST API. So you can actually use the REST API documentation or the REST API calls if something's not working in the Python API to help you troubleshoot. I'm going to give an example of that. So I'm going to share my screen. So here I have a GeoNet post where users asked a question about a parameter in the GeoAnalytics append data tool in the Python API. They weren't able to figure out the field mapping parameters. They've pointed to the doc in the API that they've been looking at, and they couldn't find it. I was able to answer this question by pointing them to the REST API documentation. So I'm going to show you what that looks like. So here is the Python API documentation. This user was doing the absolute right thing, and they were looking at the append data. They were trying to figure out this field mapping parameter, but there was no example of how this parameter was actually laid out. This is an issue. We are definitely going to fix this, but in the meantime, they were able to work around this by looking at the REST API documentation. So because the Python API is built on top of the REST API documentation, in a pinch, the REST API documentation will give you the help that you need. So here, for example, we can see we have those same parameters, the input layer and the append layer, the same as we see here. And then we have the field mapping parameter. Here in the REST API documentation, we have an example, so the user was able to get started on their workflow. This isn't just something for GeoAnalytics tool. For any documentation that you're looking for in the Python API, and if it doesn't have the details, it might be available in the REST API documentation. In addition, there's also conceptual help in the core documentation. So for example, because this tool, append data, is exposed in Enterprise, we have conceptual help that goes through examples of how you want to use the tool, some usage notes, so how you can use one parameter or another, and any caveats for the tool. This is really helpful if you want to look at more than just the API documentation and want to know more about the tool. We also include an example with the Python API for each one, so you can see a full workflow with that tool in one place. This is for tools, but there's also conceptual doc for other things like big data file shares. So if the Python API guides or Python API or the reference don't have enough to get you started, you can also look at core documentation to learn about the concepts. So I just walked you through an example of looking at the REST API documentation when the Python API documentation didn't have the details that we needed. If you ever find that something's not working through the Python API and you're just not sure if there's a Python API issue or a tool issue, you can always try the tool out in the UI, like the portal map viewer. And as I mentioned, there's more conceptual help in the Enterprise documentation. The additional bullet here is if you don't know what to do, if you can't figure out a parameter, you can't figure out why a tool is not running, you can always ask on GeoNet. We reply pretty quickly for Python API questions especially, so feel free to ask there, and as long as you have kind of keywords like Python API and GeoAnalytics, we will definitely try our best to answer. I'm going to include a link at the end so you know where to go ask those questions on GeoNet. The next tip I have is a code trick. Oops, there's my images again. So this is the future option. So this is a parameter available on all of the GeoAnalytics tools and actually on any geoprocessing tool like standard analysis. And it's a Boolean that allows you to return a GP job instead of just the result of a tool. So you can see here I've highlighted future. This is pulled right from the doc. It says optional Boolean. If true, a GP job is returned instead of results. The GP job can be queried on the status of the execution. This returns this class, the GP job class. You can see a bit about it, the future GP tool. It can provide the job ID, a whole bunch of different information. But why would you actually want to do this? So the thing I like about it the most is that it updates on the status of the job. So instead of running a job and just waiting for it to complete, you get an object back right away that you're able to query and see if there's any messages or how the job's actually doing. You can make sure it's running, you can cancel it, and you can also do things asynchronously. So you could submit an analysis job and then do a bit more of something else, and then you can come back and be like, okay, is my job finished? You don't have to sit there and wait for your job to complete. So I'm going to show an example with a demo. So here I have a script that I've written just to show you a quick example of using future with true or false. So I've just done the regular stuff. I've set it up, I've done my imports, I have made sure that I've created my GIS object, and I've just found a layer that I'm going to use for analysis. I have two jobs here. So the first one, I'm running aggregate points. And these inputs are going to be the exact same, so two jobs with the exact same inputs except for this future. So output 1 is going to return the result of the aggregate points job because future is false. So this is the default, and it just returns the item that you've created. In my second job, I have future equals true, so I'm going to get a GP job object back. From that GP job object, I'm able to check if it's done, and then I'm looping through when it's done to print out the most current message. Because if you don't do this, if you just do future equals false, you'll only get warnings and errors and you won't see the status messages. I prefer to see the status messages because it makes me sure that my job is actually running and I'm able to see if there's any additional information that's important. And then at the end, I just check that it's done and I return the result just to show you that I can get the result back. So I will get the item just like the first job, but then I also can use the GP job object. So I have started running it. We're currently right here on debug. So I want to show you the debug parameters as we go. And so I'm going to run that first job. This is just a small job. I'm just aggregating a few points into bins. And let's see what we get. So we're going to see the output one, which should just be the layer. And this is just the default. If you ever go run analysis, it's just going to return the layer. So we see that the job has started. I see a warning message returned. Another thing of note is you can't actually tell from this log if it's a warning or an error. It is a warning. In general, most of the warnings are fine. They're just to let you know that something isn't expected, but it might be okay. In this case, for example, it says bin generation and analysis requires a projected coordinate system, and we've applied a default coordinate system. This is totally fine. You can keep it as is. It's just because the necessary inputs were not there, and so then we corrected it. So when we see the result of this job, it's going to highlight here, and we're going to look at this object or output 01. So there it is. So if I go to output 01, you can see that I have an item title and it's a feature layer collection. So this is pointing to the feature service that we've created as an output. Now let's run the second job and see what it looks like. So in this case, I've put the debug line here. So we're going to just check what the GP result looks like. See how much quicker that was? Immediately, we just get status update. So if we look at the GP result, it's a GA job and it has aggregate points. So this is the job ID and we can actually see a bunch of messages. So instead of just that first message that we got last time, you can get a whole bunch of messages. I've made a script so that it can just update us, print the latest message. You can do something different. Because I've debugged, we won't see all of them because we've kind of paused and it started loading a whole bunch of jobs. But you can see here that it's printing out the messages as they come through. So 0 of 4 tasks completed, 1 of 4, 3 of 4, 4 of 4. So it's moving along and completing that analysis, which is a lot more informative than what we saw here. You don't need to do this. This is just something I personally prefer, and I think many people would like to see the status messages as they come through. So we see a layer was created, which is awesome, and that the job succeeded. So let's look at this GP result again. And we can still see it's a GP result. Once the job is done, I save it. I save the result object to output 2. And we see that output 2 is an item. So exactly the same as before. We don't lose any functionality when we do future equals true. We only get additional information. So we can see the GP job, it was a job object, and then the result was a feature layer collection, which is pointing to the feature service we've created. So it's exactly what we expected, but it gives a lot more information and control over the job. You could also do something like if the job takes longer than 2 minutes, cancel it and control the job that way, because sometimes if you maybe don't have the resources or you did a job that's way too big, it ends up taking longer than you want, and you want a way to say, hey, let's stop the job, let's move on, do something else, or rerun it with different parameters. So using the future option is the last tip that I have. Other than that, we really want to thank you for your time. We hope we've given you enough to get started with GeoAnalytics and the Python API. I've added a few QR codes here so that you can go and get started. We have more samples available. We didn't want to just go through a bunch of samples. Priyanka did a great job of showing us 2 that highlight a lot of the functionality, but there's more available. There's also a big data guide that you can look at, and that's the first QR code. There's the REST API help. So if you find that something is not in the API help and you want to look at the REST API, it's there. It's easy to find. You can Google it. And then also, this is the correct forum to ask questions on GeoNet. So if you have questions about the Python API or GeoAnalytics, you can ask them there and we will get back to you shortly. Thank you so much for your time. I hope you enjoy the rest of Dev Summit. And if you have any feedback for this session, click on the session survey link below. We love to hear it. We want to know what we can do to improve this presentation or what type of examples you'd like to see. Thank you so much.